Okay, so lists. Now the question is how we actually are going to define these things. When we are talking about arrays, that's pretty easy. So similar to how you were defining the variable types, you write the variable type, the name, and the new of that. This time, instead of just using the variable type, you're using open and close brackets on that. So if I basically copy this code and then go back to Rhino and write it here, or I can basically paste this. You see there is like a int numbers something, and then if I run that, you would see 20, which is the second item. Okay, so the point is that if you want to add something to that, so if you say, for example, numbers dot, you see a list, and then there is the append, and then if you append like 5 to that, and then run the code, so you still get 20, but this means like you have 5 added to that, like 1, 2, 3, and then it's appended something to that. So there should be like an index 3 as well, right? If I run it, then we get a problem. We get some issues. So what happened? We have to go check what's happening with append, and this is a task that I suggest you check for yourself to see how this works, because with arrays, okay? But because I don't want to basically like get into these arrays a lot, and we basically want to continue a bit faster with the code. So now if I want to define a list, how can I do that? Let's say a list of integers again. This time the declaration is a bit different. I don't remove it from here, so you can see both of them at the same time. To define a list, because list is a bigger type, is a bigger class, is a bigger typology for Grasshopper and for C#, we have to start with list this time. So we would say list, then int, and then we continue. So the rest is similar. For example, we can say nums equals to new list of nums, list of int, we close, and then we should have open and close parentheses, because this new is basically calling a function of list. So if I run this, is it fine? Yeah, everything works, but nothing happens. I don't have anything in the list. So how can I add something to this list? There are several ways. One way would be initiating the list with some numbers from the beginning. How do we do that? When I have this code, I can open and close curly braces here, and then start writing something like 1, 5, 10, 25, 65. So I have already some numbers added to that list. So if I say here, instead of console.writeLine numbers to, say nums of 2, and then I write, I would say 0, 1, 2. It gives me 10. If I say nums of 10, I would get an error because there is no 10 inside there. Okay, because we're talking about the index of 10. 0, 1, 2, 3, 4, done. Okay, I want to add something to that list. How can I do that? I can say nums dot add. What do I want to add? 25. Don't we have 25 there? Doesn't matter. We can have two 25s. So it's like with this 25 would be 0, 1, 2, 3, 4, 5. Okay, so I can say element 5 and play again the code. This time I get 25. Okay, So I can have this add system as much as you want. So it's like add, whatever, and add 35, 5, whatever, and I still add to the list. Or I can remove one of the items. So I can say nums dot. You see a lot of basically things. You have add range, so you can add a range of numbers all at all. Aggregate all, any, append. Like there are several things. There is a remove also. So it's like remove. If I use remove and open the parentheses, what do I have? There is int 32 num. So you remove something. If I say remove 1, what happens? Does it do something? It did something. But what happened? The num5 changed, right? Because back then, if I was not removing, num5 was 1, 0, 1, 2, 3, 4, 5, which was 25. Now I removed 1, so it went there and it found 1 there, which was this one, and it removed it, and then yes, index 0 is number 5, and index 5 is also number 5. I mean, I make it like 666, so you are not getting confused because it's not showing me that one. Now number 5 is basically 25, and I make this like 555. Okay, so now number 5 is 555. Is not 555. Okay, then if I basically remove 1, so the question is, which one did we remove? So we said remove 1. Let's show index number 1 too, right? What did I remove? Yeah, I know. Exactly. I removed the index 0, which was 1. Exactly. If I want to remove an index, I should use remove at, and it removes at a specific point. It removes a specific index. Okay, so the question is that now I have a 5 here, and a 25, and a 65, and a 35. So what if I had like 2 5s? And if I write remove 5, would it remove all the 5s that I have or not? We don't know. You can guess? Let's see. How do we see that? We could start like writing several console write lines and then start investigating this, or we could do something much easier. We could use a for loop to run that. To use a for loop, we have 2 ways of using loops for lists. I mean, we have several ways, but 2 is most common. So one way would be we want to use a normal for loop. So this would be for int I equals 0 to I less than what? Less than how many items are there in the nums? We have a properties for that. You can say nums dot count. In array, it's length. Yeah, I think so. Wait. Why am I not finding that? No, it's count. I'm sure it's count. What am I doing wrong here? Something is wrong here because something is weird. So the system that is working here is not understanding things properly. Let's say nums dot count is here. So why it was not working properly there? Nums dot. I think this is something with this. This is the grasshopper environment, I guess. Probably it should work. Right? Nums dot. Let's try, see if it works or not, because this should work. It just doesn't show it to us. So I equals to 0 to I less than nums.count, and then we would just write here console.writeLine. Okay. Console.writeLine I. Is that clear? What's happening right now? So this is so funny. That's why I really don't like this editor, because I mean, I know that there is a count inside there, but you could basically get confused. So if I press dot and I want to write count, it tells me whatever you want to write doesn't exist. This is super weird, which there is a count, but it doesn't work here. If I go to Visual Studio, you see that it works. It doesn't matter there. This is only Grasshopper issue. But it also again works. So the point is, in the lists we have a count property that tells us how many items are there. Okay, so I can actually here also say on the top console.writeLine nums dot count. Okay, and I run it, and when I run the whole thing, first it tells me 10. Let's make it kind of something more clear. So count is 10. Okay, now it's like 0, 1. It's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which means 0 to 9, 10 elements. Okay, so now if I say nums dot remove 5, one of you guessed that it will remove only one of the 5s. Okay, let's see what happens here. So we had like 1, 5, 10, 5, all of them. Let's play. It removed the first 5, and then it discontinued. So your guess was correct. But now if I have it 2 times, does it remove the second one too? Yes. So every time it's fun. No, it's the content 5, exactly. Yeah, yeah. So if I want to remove item number 5, what should I do? I should say remove at 5. And now it's like 0, 1, 2, 3, 4, 5. It will remove the 555. You see, there is no 555 anymore. Okay. So this was the hard way of going through the elements, but sometimes we need it because sometimes we need to do something with the index, and the for loop already counts for us. Okay. So the other way that we can do is we could basically use a different format of for, which is called for each. If I write, you already see there is a for each template here. So how does for each works? With for each, you define a variable for inside the scope of the for each. So it can be var or it can be whatever. So we know that our list is a list of integers. There is a thing that we call list of t, and t is a type. So list of type, list of int, list of point3d, list of KERF, list of humans, list of monitors, whatever. So list of t, this t is the type. So it's a list of int. And basically this var is the type that you have here. So usually in a for each we can use var, or in any other place that the type is explicit and we know what is the type, we could use var. So for example, the question is, can I use var here? Yes, because we are already defining that we are defining a list of int here. Okay, or I could even make it easier. I could say var z equals y equals 10. And this works in C#, in recent versions of C#. It did not work back then in old C#. Why? Because then when I go to 10, it doesn't show, I guess, here in C#, in Grasshopper, but in .NET, it also shows you that, hey, you use the var y equals 10. I consider 10 as an integer value. Then I already define y as integer. So the compiler decides for you. So the point is, if you use var, you need to understand and you need to know the behavior of compiler to avoid some errors. If you don't know the behavior of the compiler, don't use var. Okay, but I'm just telling you because that makes your whole life much easier. It's like, imagine like here, every time I want to say list int, then list point3d, then list char, and then again list int. So I write it 2 times. It's not necessary. I can say, for example, var nums2 equals new list double, and then 5, 20, 30, 50, and something. Okay, I forgot to write the zeros. Yeah, we had this in JavaScript back then. We had this in JavaScript. We had this in Python. I mean, in Python we don't define anything. It's just like that. It's in there. That's the point. Yeah, that's what I really hate about Python. I love Python for many cases, but that's the thing that kind of it makes me uncomfortable when I'm coding in Python. But actually, that's a power that it has for some unexplicit things. But Java had it back then. But C-based languages, they hated it. But I guess specifically after the advent of Python and slowly, I mean, they are kind of the same age in a way, C# and Python. They started to appear around the same time and become popular. But then Python was growing so fast. So the changes in the recent years, in specifically last year in C# is that they are adapting so many things in Python that are making life for programmers much easier, because they realize that if they don't do that, people start to move away. I mean, they already did. So specifically because of AI, Python became a few days ago the most used programming language in GitHub Copilot. So that's the first time that Python has the biggest number of uses. But well, they are trying to come back to the scene and be powerful again. That's why they're making it easier in C#. And I think C# is also one of the languages which is gonna stay strongly till for a long time. It's been great, and it's developing. Yes. Hmm. It just makes your life easier. Instead of integer, because probably they are both 3 letters, it doesn't matter. But for example, imagine that you are going to define a list of a class which is called, for example, isotope ijk link booleans of terrestrial space, for example, whatever. Then this is the name of your class. Then you should say equals new, again this. You see, even selecting it and copying it is a big pain. And then you define whatever value you have there, and then done. So it's a new list for you. Okay. But I mean, I forgot to even write what is the name of this variable. It's like terrorist1, for example, whatever. So it's like we wrote something like even the name of the variable is hidden between there. But instead, I could say var, because I'm already declaring the class here. I'm declaring what's happening here. So I don't need to do this 2 times. This is one of the stupid, this was one of the stupid things of C# that everybody hated. That when you want to declare something, you have to do it 2 times. I should write it here, and also I should write it there. Why? Are you so stupid that you don't understand? Then they changed the language and they made it much easier. So now you can say, okay, it's a variable, terrorist1, as this list. Okay, got it. And then for some static types and basic types, they made it even self-understandable. Why? Because this existed in Python. They realized that, okay, they have to make life easier also for some people who start programming from the beginning. And so it's, I can imagine it's really difficult for so many people to decide like, hey, I want to declare a variable. Should I declare integer? Should I declare double? What is double? Am I doing the right thing? Should I declare float? Should I declare decimal? Forget it. I'm not going to program. I'm going to just use grasshopper. And believe me, I've seen people just because of that, they gave up. But in Python, you do x equals 5. Done. I don't think even you need a def. I forgot. No, you don't need a def. You say x equals 5. And suddenly x exists in the memory. And it decides what happens. Here, C# says, hey, okay, I cannot kill every part of my syntax, but you say var x equals 5. I decide what is good for 5, and I make it integer. If you say 5, 0, I make it double for you. If you have a number which is like, I don't know, too big, I find a proper variable for you that fits there. I mean, actually, it couldn't find. Integral constant is too long. So in this case, you should say long x equals. We need to use int 64. So that's even too long for long. Or I can say, for example, var, and then I have some value like whatever, and then it has some thing, and then it's a float. It says, okay, you wrote f, I chose a float value for you. So it's just there to make your life easier. You can even ignore it. Yeah, I know. It's a var. On, you mean after something is declared, you mean? Yeah, you can. You can. Okay, so let's say like you have var, for example, G equals 5, okay? Then what you can do, you can say console dot write line what? G dot type, or there was a type of G, or G dot type of, wait. Yeah, there is something called type of, something like that, and then you can see what is the type. I used it before. I forgot the whole thing. These things, because they always pop up in Visual Studio, I never remember it. But then when you come here, you have to remember. It's like you have a phone which has all your contacts, and then you don't remember anybody's number. But if you have a burner phone with no contacts, then you remember everybody's number. So that's what happened to me. So because I write type of, and then it gives me the hint. So I don't really remember what is the thing. So I even sometimes I don't remember, was it big C or small c or whatever. Properties are always like with big letters. They start with big letters, but still sometimes I doubt. So what do you mean? No, because then it's not explicit. You with var, you have to be able to tell the compiler immediately what is the type. I don't think I've never used var on reference. Wait a second. I can check that. Yeah, you cannot. No, you cannot use var because it's not explicit. C# likes it explicit, so you cannot do that. This is something you have in Python, and you can make things on the air, and that is something that can cause some long-lasting debugging processes, because you may have referenced something wrong, and then it takes you ages to debug the program. Okay, so this is clear. Yeah. So then we said, now we have this. We talked about this var type, and where were we? We were talking about for each. So when we use for each, it says var, which we take it as granted. It's var item in what collection. This item could be anything. Could be item, could be could be like, I don't know, anile, whatever. It's just the name of the variable that we define. Var anile as var. In what collection? Why var is accepted here? Because this collection should be existing collection. So when I say nums, var anile in nums, or var item in nums, or something which is actually very much common, is that nums stands for numbers, right? So you say var num in nums, var number in numbers, var item is in items, var, I don't know, cat in cats, something. So it's like you're using a plural and singular form to define it, and it makes your code much clearer. So var num in nums for each variable type. Num in nums. What variable type? I know nums is an integer variable type. So here var for me means int. You can write int num in nums, or you can write var num in nums. I don't care. I know what to do for you. So for each var num in nums, and this is helpful because sometimes you actually don't remember what was it. You want to go up there and look. You don't remember. Did I define it as like this class or that class? Whatever. Doesn't matter. I see here. Grasshopper finds it for me. C# finds it for me. So here you would say, now console dot write line num. So I don't need to think about the index, anything, count, anything. It says for each var num in nums. For every number, for every entity in the nums, go find each entity one by one from the beginning to the end. Each entity you find, put it in a variable called num, go to the scope of for, do something with that num, and then when you change, find the next entity, put it in num, and then go here. So basically what happens here, again, if it's wake for you to make sure that it is not, what happens here is that as soon as this for each begins, what do we have here? We have basically a, oh, this is off. We have basically a memory cell defined, and these four goes to this list of nums, and it says, okay, this is my first round. I found one item in the for each, and this item, which was somewhere in memory, has a value 1, and it has a reference. Nice. So there is a next item. So put 1 in this memory cell, and this block of code only understands this memory cell. Okay, so send 1 to here. Right line, this memory cell. Okay, it's 1. Okay, there is a reference. What is the next item somewhere? This is connected to here, and this is 5. It has also a connection to another thing somewhere in memory, which is 10. Okay, it's here. So, okay, the second one, read 5, put it here. Hide 1, put 5. Read that memory cell, that's 5, send 5. Okay, what's next? 10. Remove, put 10. Read that memory cell that I gave you, and it's called num. And so on and so forth. Is that clear? Okay. So, this is the case then. So with for each, you can go through all of these. What's happening? Oh, you can go through all of these items in. Not really. It's a compact, easy for. Yeah, yeah. That's exactly what it is. Yeah. No, there is no even like in terms of being fast or not fast, they both operate the same way. It's the same logic. Yeah. It's like Miriam, Mary, they're all the same. Names referring to the same memory. That's the same thing. So then that's it for this list. Let's go here again. So we defined lists. We went through lists. We saw, okay, there are methods that we can use to do something to the list. Lists are dynamic. We have indexing in the list, which starts from 0. We can initiate lists easily, or we can change the values inside the list, and we can search through the list, find something, and there are several operations that we can do in the list. There are other collection types in C# as well, like dictionaries and queues, which I'm not going to talk about right now. But you can always like do some search and find things in C# in .NET online library and learn everything. Another thing which is important for us before we dive into the code, into our code, is a sort, a derivative from lists inside C#, which is data trees. Okay, so you're definitely familiar with data tree types, okay, because you have been using C#. So inside C#, generally, apart from everything that we have here, you know that inside C# we have things called data trees. So I can have a list of, I don't know, numbers, and then I turn it into a data tree. And with data trees, I have addresses. And addresses in data trees means that you can have, I don't know, addresses like this. Addresses like, I don't know, these curly braces, and you say 0, 1, or you can say 0, 1, 0, 1, and then 0, 1, 0, 2, and then, I don't know, 0, 3, or whatever. Okay, so you can have all of these sub branches inside Grasshopper. If you want to have those if you want to transfer information, and if you want to talk with Grasshopper in these sort of data structure, you have to use data trees. Okay, so the point is, these data trees, there are some things good about data trees and some things bad about them. It depends what is the situation. So most of the time, if I'm dealing with one-dimensional or even two-dimensional things, I'm working with lists of C# because it's easier to go through them and then to work with them. But if the dimensions grow, or if I need to define something that definitely needs a format of data trees in Grasshopper, or I'm receiving information from Grasshopper, which is a complex data tree, then I definitely need to work with data tree. I mean, my personal opinion is that I'm not really a fan of data trees in Grasshopper, but well, we have to use it. There is no way around it at the end of the day. But the definition of them is very much similar to the lists. So instead of writing that list object, list of t, you say data tree of t. So it's a data tree of what? Data tree of integers, data tree of whatever. So you can say, okay, make it, and it's common to make a data tree of objects in Grasshopper. Okay, but you can do different things as well. So we define, for example, here a data tree of object as tree equals new data tree of object, open close parenthesis. Then, how do we send things into the addresses of data tree? Every time you want to declare something and send something into the data tree, you need to define a path, a Grasshopper path. And we have a class called gh_path, which is which declares the path. So you basically write, it's a type, you basically write gh_path. This is similar to when you are writing int or double or list or something. So it's gh path space, the name of the path, path 0, whatever, equals new gh path. Okay, so I basically assume it should work that you can say also var path 0 equals new gh path, parenthesis 0. Okay, so this is called path 0. And then you make a path 1. Then you have two specific defined paths. Okay, and you can say what? You can say, hey, tree, you define this tree, tree.add hello. Where should I put this hello? In path 0. Where should I put world? In path 1. And then if you get the list, you get these two. And then you say again, tree.add 42 into path 0 and 100 into path 1. Okay, and then you can go through all of these elements and see them. Let's copy this code, put it in Grasshopper, and see what happens. So here, I write this code here. I'm just ignoring this part of for each, because that's what I wrote for a console. And then let's export it and see what happens out there in Grasshopper. I can say a equals tree, because the name of my data tree was tree. Okay, I run it. It runs fine. There are no errors. Let's make a panel and a. Amazing. We have curly braces 0, hello, and curly braces 1, world, and 100. This is very clearly defined. Okay, so if I receive some data trees inside my Grasshopper, that's the same way that I can handle. Okay, I can find the paths, analyze the paths, see how many paths are there, and then go through the elements. Okay, so Yeah. Yes, you can. But I think, as far as I remember, the searching is not as easy. At least you need to go through the items and search and find for yourself. But this might have changed also in Grasshopper 8. I actually did not use data trees that much in Grasshopper 8, so my information about it is not really up to date. And I used it once actually a few months ago for something. It was like a three-dimensional data tree, but I explained it actually to ChatGPT and I said I want this list to be translated to data tree. It gave me a code. I checked the code. It seemed correct. I used it and it worked. But I actually did not go and inspect every line of the code to learn what happened there in data tree. Because of the situation, I realized that okay, I hate data trees. I don't like their structure. ChatGPT is there, does the work. I check. I make sure it works. It works. It's just a conversion thing instead of me sitting and defining everything. So this is actually how most of the time when I want to define something and I don't know where is the library or I don't remember the library in Rhino, I go to ChatGPT and I ask about the library that turns or function that turns, for example, a polyline to a NURBS curve. How can I turn polyline to NURBS curve? It gives me the functions. And sometimes it was hallucinating also. So there were times that it was like assuming that a function exists which didn't exist. This is also something you should know. So then but okay, this way is actually not very interesting because like if I have a very complex form of path, this really doesn't work. What if I have like 0, 1, 0, 2, whatever? So what happens if I here write 0, comma 1? Does it work? Yes, of course. This path would become 0, 1, and this path would become 1. And that's why. And what if I actually, what happens if I have another path here? If I have a if I have a var p2 equals new gh underline path of 0, and then I add 3 dot wow comma p2, and I add actually I didn't write add, and I actually can do also 3 dot add oh wow 2 comma new gh underline path of 1 comma 1, parenthesis close, and then enter. So when I run this, you see that we have 0, we have 0, 1, we have 1, we have 1, 1, and everything is there. So you actually didn't need to basically define this new GH path also before. You could do it instantly inside the parameter and don't store it somewhere. So you just threw a new one and then you sent it there and it's using that address. And the reason, yes? No, you need to write new. It's a new instance of the class. If you don't write new, it doesn't work. It shouldn't work. Because I newed the P2 back then here. Yeah. Okay. Now the point is, now maybe you understand why I hate these paths. Because in my understanding, if this is a branch 0, 0, 1 should be under 0, but it's not. It's a separate entity. So there is a 0, which is whatever, and there is a 0, 1, which is whatever else. And they don't have any actual physical relationship. So they are not in the brain of grasshopper, as far as I understand. They are not. It is not a box which is 0 and everything which starts with 0 is inside this box. This is a box labeled 0. This is a box labeled 0, 1. This is a box labeled 1. This is a box labeled 1, 1. It's only classifying. It's only the way I classify it, and then it is labels. But actually, when you use the param viewer in Grasshopper and you look at it, it's like it shows it like this to you. Okay, so it says that okay, I have a source, I have two sub branches because it's 0 and 1, but it doesn't show it like that here. So I actually don't know what happens inside the brain of it much. We should go get the documents, read the documents, and understand. But that's somehow like that. So it's in 0, 1. Mm-hmm. Mm-hmm. Comma 2. This doesn't work. No, you should try. If you want to write, you should say new gh underline path, and then, for example, 2. Please work. Okay, 0, comma 2, not 0.2. Yeah, because it's a different branch. Mm-hmm. Yeah. It says it's 0, 1, 0, 2, 1, 1, and then again this one. So it's like it's like it's a very, in my opinion, it's a messy structure. I don't like it. I hope David Radden doesn't see that video. But the point is, we have to use it. Then another situation is that this way doesn't really make sense to do things, and this makes it messy. So how do we do that? We can do all of this in a more automated way. So one example that I wrote here is that imagine that I am having this data tree of object, and I have two for loops inside each other. And inside those for loops, I want to declare the elements of this tree. So for example, I want to add two elements into this tree. So what happens here? I have a data tree. I have the first for int I from 0 to 4, I++, int j from 0 to 3, j++, and then I want to add one substructure for each of these guys. Okay, and then I would say a equals 3. Okay, then we run it, and now we see that, okay, interesting. So we have 0, 0, 0, 1, 0, 2, 1, 1, 1, 0. 1, 1, 1, 2, 2, and it continues to show all of these items. Okay, but it tells us that this is a sub branch of 0, this is a sub branch of 1, this is a sub branch of 2, and this is a sub branch of 3. But then it continues. They have elements here and here. Okay, and when we look at this panel view, we see, okay, we had the first item at 0, 0, second item at 0, 0, first item at 0, 1, second item at 0, 1, whatever. So this way, actually, you declared something which is structured, and then you can also read it the same way, structured. Is it clear? Okay. So this is how to deal with Grasshopper with data trees and GH path classes inside Grasshopper. But what next? I do have a comparison here also that I sometimes talk about, but this is getting like too much. But this is something that you can also compare. Like there are times that it is good to use list of lists. There are times that it's good to use data tree of T, or it's possible to use data tree of list. So you have to know them and you have to decide what's good for when. There are like pros and cons for each of them. Just like to talk like very kind of um, abstractly about it, is like lists of lists is basically good for the time that you have only two levels, two dimensions. With data trees, you can have more dimensions. With data tree of lists also, and then list of lists is actually less complex. So if you have two-dimensional things, it's much easier to use list of lists and then just translate it to data tree and send it out. But you should know, if you send out a list of lists in Grasshopper, it doesn't understand it. So if I go here, and if I have, for example, let's do it inside this for. Yeah, that's true. So if I say list int, so var kj equals new whatever, and if I say a equals kj, I delete this, whatever. Kj is now empty, but whatever. I don't get anything. Let's add something to that. So to do that, I have to do two curly braces here. So the one is like 1, 2, 3, comma, again like 2, 5, 6, comma, 5, 5, 5, for example. And that's why we are using these enters, and it doesn't matter in C#. So this way you can basically make your whole syntax more clean, you see? So it's not confusing at all. So if I write this, you see, I get a list of 3 things. So a list of items is understandable for the output of Grasshopper. But when you have a list inside a list, it says, I get a list with 3 entities, which are system.collections that generate that list. I don't know what it is. Do whatever you want. So if you want to input that, you basically have to have a method here. I actually wrote for myself methods of like that. So it's like a list of list to data tree, list of list to data tree, things like that. So I just give it a list. It just like breaks it up, turns it into a data tree, and sends it out for me. So it's like 0, 1, 0, 2, 0, 3, something like that. I mean, in this case, it would be 0, 1, 2, and each of them are lists. Okay, or it graphs it or not. So sometimes it's easier to use this one. Sometimes it's easier to use data trees. Okay. That's it for here. Let's go now to the, let me check the list of things I wanted to say. So this is done. Data trees is done. We start the coding. We start to check the components coding. Okay. So just give me 1 minute. I'll be back. I just need a glass of water. I come back. Before I start, I want to mention something. Last session, yesterday, if you remember, I tried to define a class inside the online compiler of Microsoft here. inside the online compiler, and it didn't work. I did a search afterwards because I always use this for top level codes to do some tests, these sort of online compilers. I never in my life did try to define a class here, and I didn't know that it actually doesn't allow you to have that level of coding. So you cannot define a class here and then use it, because when you define a class, you need to have a main and a main method and a program method and everything. So basically, back then, the point was, let me show you visual. Whenever you open a basic code of Grasshopper in Visual Studio or something, you always have a main method, a program method, and some things. And this whole understanding defines a bigger scope of thing. And then those classes are defined inside that scope. And then you start defining them, and you define the main method. And when the program runs, it runs the main method, and then it can declare the classes and everything. But in this area, we don't have such an entity. That's why we cannot basically define anything like a class. And then I tried to do it and it didn't work. Then we went to C# and then we went to Grasshopper and it worked. The reason it didn't work is that it's actually not possible. So you can only use such compilers for top level codes, statements, checks, and stuff like that. Just that you remember this. Okay, then let me show you this whole situation of the component. So the first thing that we tried with this component was such a thing. So what's happening here is that we have these KERF cuts here. And because of these KERF cuts, we have a limited rotation based on the material type and the geometry. Okay, so basically, when we were using this thing, we realized that okay, if this is let me draw with my path. If we basically draw, if this is the KERF line, and this is the rest of the material, a sort of basic hinge point happens here, and then this hinge point actually defines the rotation situation. And of course, these 2 points can never go beyond each other. So basically, this shape here would start to rotate around this axis. Okay, so we would have something like this, and we would have something like this, until, if possible, they reach each other. And then basically this would be the shape of the curve. Okay, I think this is clear, right? Okay, so this was like a geometrical representation of what's happening, and this is what my students tried to do with Grasshopper, and they managed. Then we also got a coefficient and a tolerance of like the material, and then we realized that when we have 2.5 millimeters of leftover material with that specific type of plywood that we used, and with the KERF width of 4 millimeters, we add on a 15 millimeter of that material, we would get a behavior which is actually with a coefficient close to this behavior geometrically. So we only try to do the geometrical simulation. Okay, so the point with this geometrical simulation, the problem with this geometrical simulation is that when you have a very simple shape, when you have like the lines like that, it's very simple. It's like a simple rotation. But then each of these lines are this one. There is one axis here. The axis is different. Here, the axis is different. And then because of that, the shape actually changes, right? So there was another problem here, that when you are bending this, you have only a very thin layer of plywood here, which is very fragile. So when you bend it, if you fix it, it cannot tolerate any forces, and it needed to strengthen. So to strengthen that, we tried different ways. The most successful way was to add a sort of patch, a secondary patch to this element to make it really powerful. Okay, so how does this patch works? So this patch sits inside here. So there are two pieces of plywood cut, and the patch sits inside here. So what happens here is that this patch needs to really meet the section of the plywood here, right? Which means it should follow the form of the rotation at each section. So these pieces are really sticking to each other and they're really supporting each other. For that, we needed this nice like cut here, which you see. So this cut is on each layer is actually basically parallel to the surface. This is actually the example we did with the milling machine, with the 3-axis milling machine, and not with the robot. And you see the edges. So you see all of these like creases are the situations that you are not going to have a good support of two pieces. So this is actually the not good piece, but it is following the geometry, but it's the parallel finish is like, if you see here, it's a 3-axis parallel finish. It's not a robotic parallel finish. Okay, I don't have one of the robotic pieces here. I didn't find to show you, but this is one of them. And then when this is bent like that, then one of these patches, which is a completely 3-axis operation, one of these patches would go sit inside of the piece and support the piece, and then at the end we would have something like this. Okay, so how do we get this geometry? We need to write a code for that to get this shape, lines, patterns, and everything. Is it clear so far? Perfect. So this is the situation that we are dealing with here. To deal with this situation, we basically open the code. So we basically developed a component that this component receives a lot of values. The component that I'm going to explain today is a smaller component. A part of code is there. And what does it do? It starts with a basic section that drives the whole thing. It checks this section for the width, for the thickness and everything. It gets a value, which is a KERF width, so it knows what is the width of these cuts which are happening. It gets a leftover layer. I made it leftover layer to make it easier for calculation, which is how much is this amount, the leftover layer here, which I said is 2.5 millimeter. You can define the full length of the piece. So each piece can have different length. So it could be like more, less, whatever. Then it could have the start R. So on the right side, where do you start the lines? On the left side, where do you start the lines? And then what are the distances between here? Are they equal distances or they are different? So one of them is 150 suddenly. So you see, it works like that. This one is like 50, 200, and 35. So you see, the shape is completely changeable. Okay, so how this code works? the way that I designed this code was that, okay, I get this section line, I move it in the space along the normal of this surface, so it's straight, it goes up. Then I start to distribute this start R, start L, and the distances, because then it defines where I would need lines. At each line section, I would assume a cut. I would find the hinge point, and then I rotate the rest of the section, all of them together around this corner. Then I would go to the second line. I have the rest. So when I'm done with this one, I have a piece which is from here to here like this, right? Then I go to the next section and I rotate this, then I would have a piece which is like this. Then I go to the next step, and in the next step, I have a piece which is like this. The rest of the piece is like this. Then I go to the next, and I see that the last one is like this. And then I see, hey, there's nothing else. The throw reach is done, finito. And the final shape is there. Okay, so this was the logic for this purpose. And then it gives me also this last curve, which means I can basically take this curve and copy it and then make this extension section, give it to a start section. And I have the next shape. And here I can again play around with this shape, see what happens, and then change it, do something, and play around with it. Or I can rotate the section. So I can say, I want this section rotated. So I want it to go up instead of going down. And then I can again copy that and then give this extension section to this one and rotate the section again, continue. And this is how the whole pavilion was designed. Okay. Actually, of course, it had some other parameters included, like the students had designed a basic shape idea, a sketch by what they had, and they used Galapagos to optimize these parameters to get as close as possible to that shape, and then they modified that, and then it was the final shape. Okay, so this is how you can basically start the whole thing. But what's happening inside this component, and how do we start doing that when we want to deal with ChatGPT? So yes. In this case, the bend angles are all the same, okay? Because the kerf width, the width of the cut, the leftover amount of the material, and everything is the same. But basically, with the same code, it's possible that we say, okay, the material is the same, so the coefficient of the material is the same, but it's possible to have wider cuts or less deep or more deep cuts. But this is actually something that we have to control outside the programming world first and test and see, okay, if the kerf width is more than, for example, 6 millimeters or 10 millimeters or whatever we found, then give an error to the user and say, hey, this width makes your section break. If it's less than a value, or if your leftover layer is more than a value, so for example, your section is 15 millimeter, the material is this. If the user gives you a leftover value that is like 10 millimeters, give an error. You can make, and if we didn't make this in this code, but it's possible to give an error and say, hey, sorry, you're not removing enough material. This section wouldn't bend at all. You're just cutting some material from it, but it doesn't bend. I cannot bend it for you. Or you don't give an error, you just don't bend it. And give a warning and say, hey, consider in line 3 of this section, you did not have enough depth of cut or width of cut or something, and the section did not bend. Or hey, note that here you're removing too much material, your leftover is like 0.1 millimeter. This section will definitely break. Know that. Or like Karamba, you make it loose. Like you see, we have this kind of forms in Karamba that suddenly the structure loses down its form or something. So that's the point. These are things that you can consider. So this is not a component that you sell or you provide for other people and say, hey, go bend with it. You're good to go. This is for us. If you want to produce a plugin out of it, there are a lot of these ifs that you have to produce inside this plugin. Did I answer your question? Yeah. The point is, like, there was another case that we tested. I can bring it quickly to show you. So this is a different case that here the cuts are on both sides, and then the cuts are filled with some wedges. So the form of the wedge declares the form, basically here. And for the code, the form of the wedge and the distances which are declared there are defining the code. And then we had also a simulation code to be able to get such things, to be able to design these forms on the computer based on the wedges which are inserted here. You see those wedges? So this is a step. This was a last year's project of the students. So you basically can play around with all of this. But what's happening here is let's go check the code together. So to start producing this code, we have two sides of the whole story. One side was knowing the programming. This is what I tried to teach you in last 3 sessions. The other side is your brain structure and your solution finding, which has something to do with programming thinking, but it also has something to do with yourself. So, for example, here, the solving of this angle is a mathematical equation that you need to, it's a triangulation equation that you need to solve. Or like, what is the amount of these offsets? Or when I want to find out what is the shape of the subtraction for the final shape, because if I just want to do subtractions in Rhino, you know that's not an easy thing to do with this form, with these shapes, because if you start just subtracting things, you probably get always some errors. So we had to like form and design the whole section. So instead of subtracting, we had to calculate the section. So this section inside was not that we rotated this inside shape and then we subtracted this from this. We basically calculated this whole shape here. So the question is that, and this was not by ChatGPT, this was completely manual. And not that I had anything against ChatGPT, simply I actually didn't think about it when I was calculating this. I didn't even consider using ChatGPT. Not that I had anything against it. I was just like thinking about it and doing it myself. But the question is that if you want to ask ChatGPT or Copilot or some other thing, how do you ask the question? How do you formulate the question? Would you go the same way? Would you get the same answers? Does it work as efficiently? Does it work better? Does it work worse? How do we formulate the question? And this is what we want to check in the time which we still have in the next 2 sessions that we still have on this workshop. So the question is that if you want to do this thing, are you starting with this section again, Or would you say, hey, no, I don't like it. I want to give such a section to Grasshopper, and then I would also like to provide these lines for Grasshopper as section lines. And then I want my script to take that and bend it. And I want to be able to tell Grasshopper that, okay, this is the section. These lines are on this side. This line is on the other side. This is much more versatile than what you produced. Of course, it's more versatile. It's a different thing. It's interesting. It can be. It's actually more interesting. So the point. Mm-hmm. Yeah, perfect. I would like to see how do you approach such a thing. I don't want you to like produce the same plugin, because I mean, to be honest, I had to go through the code that I wrote 2 years ago to remember it when to the moment that I want to explain you the code. I know how to explain, and I guess everybody who codes is the same. Like when you write a code, you're super interested about finishing it, making it work, and as soon as it's done, after 1 week, you don't remember anything about that code. So everything is gone. It's as if like you never wrote that code. So if someone asks you like what happens, you need to read the comments. That's why actually. Hmm? No, it happens if you are the more you are a coder, this happens more to you, because you're dealing with the logic, and you solve the logic, it's done. You don't remember anything about the logic. It's about math. So that's why whenever I code, I always have all of these descriptions, because I don't remember. 1 week after, I don't remember what was this and why did I do something. So uh, if I want to solve this math equation for you, I again need to start with paper and solve it, and then I can teach you why the rotation angle is this. I don't know now. I should remember that. So I actually have the equations on my notebook here, so it wouldn't take time. But it's like a simple triangulation equation. So the point is, then this is the code. I want to break down the code for you so that you see how this would work if human being writes it, and then also think about how would you ask such a thing or something like else from Grasshopper. So from ChatGPT or Copilot. So what happens here is that I have this solve instance, this script instance thing that we had. I have the inputs and I have the outputs here, right? So what's next? I started this code. I needed to have 3 declarations. So it's like I have a CRV, HR, or horizontal lines. It's a list of curves. You see, now you know what is it. It's a list of curves. So I'm going to iterate through the curves. I have another list of curves, which is a CRV cut poly. So it's like a polyline that defines the cut form. This is like this polyline. Then I have a CRV end section also. What is it? It's a section that I get at the end. It's this one. It's this section here. And this is like, and when I was coding this first, I actually started part of the code inside. It got to a certain point and I was like, okay, now I wanted it a function. And why did I do that? Because I still didn't know, how do I want this function to work? What do I want this function to have as output? Do I want this function to output something, or I want all the output of this function to be as references? You remember the method that we were talking like a few minutes ago, 20, 30 minutes ago? That method, one of them had one output, one of them had 2 outputs or 1 output inside the method, right? So how do I want these to have? As you see, the function that I defined is called geobend, geometry bend. It has some inputs. It has the KERF width, it has the leftover layer, it has the start section, it has the Boolean rotate section, Should I rotate it or not? It has the full piece length, start R, start on the right side, start on the left side, the distance list on the right side, the distance list on the left side, and it has a reference CRVHR lines and a reference CRV cut body. So these are two outputs, correct? And hey, I wrote CRV end section equals geoband. So I actually have three outputs from this one. There is a bigger version of this component, this geoband. If we go here, I can show you. So this geoband has two overrides. One of the overrides is here. One of the overrides has this much outputs. You see, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Right? So it gives me CRVHR lines. No, actually it's more. It gives me CRV cut poly. It gives me the list of B reps of the shape. It gives me the middle lines. It gives me the distance of the patch. It gives me it gets the distance of the patch. It gives me the list of the B rep patch. How does that patch part, the second part, looks? Then it gives me the, I don't know, milling main. It gives me the milling patch. It gives me the milling main region, milling main profiling, KERF edge start, KERF edge end, KERF CRV milling patch curve, the KERF cuttings, BREP patch difference, patch length, parallel finish lines definer, and CRV zone. CRV zone is a profile that we got to do the 2D drawings for the whole thing. So it's like it has a lot of outputs, but this is the one that I run only at the end. When I know I'm sure the form is fine, I run it. It takes a bit longer. Then I have all the output that I need. Okay, but when I want to solve, I have this version. When I want to form find the whole process, I have this version. It has only two outputs, 2D outputs, nothing 3D, nothing sophisticated, no milling path, nothing, just the form and a section. And I decided to have this section out. This is a decision that you always have to make. And for example, this is something that you have to tell ChatGPT. And you can tell ChatGPT or whatever, what do you want and how do you want the output and the inputs of your function. If you don't do that, it can produce something which is really not helpful for you. So, but if you start doing this, so if you start having a blueprint of your code, defining a blueprint, define that blueprint for ChatGPT, and then ask ChatGPT to use the proper functions, do the proper math, do proper things, and then solve everything for you, then it's a higher chance that you get a proper code out of that. And then you don't need to be a proper coder, but you get a proper code. What's the question? What do you mean? What do you mean a pseudocode? Ah, yeah, yeah. Yeah, kind of. Yeah, part of it. Like part of it, it can solve. It can help you solve. But sometimes, sometimes it's also better if you have different questions. You can open different contexts. Okay, so you can have different chats. So one suggestion that I have, if you do such things, don't allow ChatGPT to remember your history, because by remembering your history, it's when it starts to give you shitty answers, it continues forever. So don't allow your history to be there, not just because of privacy, but because of solution finding issues. Because then you can have different chats. In one chat, you ask ChatGPT, hey, how can I solve the geometry of this? I don't know. I'm not a programmer. I just want to solve a geometrical thing. Think as a mathematician. Then I open another context. Hey, think as a machinist. How do I do this? Then you put those together. In the third tab, now think as a programmer. I know this, I know this, I want to do these two together. And then it can patch it together. So still ChatGPT cannot do those sort of inferences that human being can do properly. And I would say whenever it even can, you as human beings should be able to do it more creatively. So I'm never worried that like machine learning or artificial intelligence would replace us. The problem is that so many times whatever people produce is banal things that ChatGPT can produce easily. If that becomes our content, then of course, yes, we are doomed. But if we start to use that and produce creative things, it's never going to replace us. We are thinking about those like different inferences. So the point is, how do we define that? So for example, the question is, why did I want this curve and section to come here? Because at that moment I thought, if I want to start like a recursive thing that things go together, then what I can do is that I can make geoband blah blah blah, instead of start section, say another geoband, and geoband into geoband, and make a geoband into geoband into geoband into geoband, and make a recursive thing that continues doing things, and then it behaves like a never-ending loop. So I thought that maybe that's interesting. I never used it later, but then that was the motivation to see, okay, what do I want as output? Something that I can input into the next one. The main thing that I need as an input of the next one. And as you see here, the main input of each element, all of them can change. But the input that has to change is from start section to extension section on this sort of code that I wrote. Everything else can repeat. So I can just copy this and get start section. All of the parameters are the same. So this is something that I do it here now, but I can have this as a for loop easily. So with a for loop, I can continue doing this and get this like constantly rotating around. And then I can have a proper spiral or whatever. Yeah. And for example, maybe you want to close a spiral. So you know the numbers, and then you can actually give these numbers to Galapagos to force it to enclose the spiral for you. Because if I continue, it actually does not meet like that. It is going to constantly continue. But what if I want to produce a ring? What if I want to produce a shape, an enclosed shape, a Mobius strip, or stripe, or something? Then I can connect them and then try to fix the parameters. So then what happens here? So we have this geoband, and then in the next step, what do we have here is the output. So it has this CRVH line, CRV cut pulley, and then curve and section. So extension section would be curve and section. So it defines the extension. Curve lines, CRVH lines is the horizontal lines, and then bending information is the public variable that I define, which gives you some. Did I put it somewhere? Yeah, bending information. It gives me some information. So it's like, so bending results and the details. So section curve, point count, 5s, and then material width, 19. So it's like some information that might be helpful. So then the curve polygon, and then what happens here? So I have a public polyline geoband. Then I needed to define a tolerance. This was basically for my calculations. I needed to know the tolerance of the document for the B reproductions. Actually, it's not, I guess, used at all here. So I can Control F. Yeah, this doc tolerance is basically used in the other geoband component, not in this one. As you see, it's only used once. So if you want to see why did someone produce this code, you can basically select that. Then it's like curve CRV base. I define the CRV base, a polyline curve, as a new polyline curve. Then I define the polyline as a CRV end section as a new polyline. And then I'm checking some things. So I have a PL length adjust. This is something that I thought, okay, maybe the curve that they give me, I don't know, the first section is the small section or the second section is the small section. I need to adjust that. So I make sure, I check the length, and I make sure that I always consider a unified form for my curves. So if the first section is the shorter section and the second is the longer section, then I shift the curve once and then I make it different. So every time I know that section, I know that the line between point 0 and point 1 is the longest and is the base of my operation. And the second one from PT01 to PT02 defines the thickness of my section. So I can use that and continue for everything. So then I define, if I should shift right, then I find the interim line, which is the section that the hinging, the rotation happens. Then these ones are like, if I Control F, you see, this is a function that I have defined here. So this is like public polyline PL interim. So because I needed to use it, I did it here. I made sure this works. Then I don't think about it. I just use it whenever necessary. It gets a source, it gets a source, it gets a distance. It gives me an interim line from the distance of that thing. Okay. Then and I was like defining this change of. So from here, these are all the other functions that I'm using in the code. So then we have and you see I have all of these infos that I mentioned before. So I have an info which gets a description and a value. So I would always, if I want, I would always see what's going on here. Okay. Then we have this plane, PLN section. There's a plane defined, a new plane, and I'm using the CRV section points. So here you would see that polylines behave as an array, as a list of points. And when you have a polyline as a class, which has like 0, 1, 2, 3, 4, 5 points, it automatically draws lines for you between these points. And if you have the point 0 and the last point on the same location, it becomes a closed polyline. Okay, so I defined a new plane here. And if you remember, I said something about like these operators and how they work. So for example, here we see that a plane is a point usually and two vectors. You see, I gave the first one a point. This is the point, the base of the plane. Then it's CRV section 1, the first point of CRV section, minus CRV section 0. This is x vector. CRV section 3 minus CRV section 0. This is y vector. So I have a plane easily. By having a rectangle, I have a plane. Polyline rectangle, I have a plane. Then I would make a vector from the z-axis of that plane. That is the direction of my extrusion. This is the direction which is along my section. Then, of course, I unitize any curve that you get, because then you can really play around with that. If you don't unitize a vector, doesn't mean anything, because you don't know what is the length. You need to get the length, try to fix it, whatever. So probably most of the time you have to unitize it and then define the length as much as you want. Then I define the point on the right side, point on the left side, a plane surface, CRV end section, and I define the section and I transform it, I move it to that place. Then I define a vector 3D, which is vector offset dir equals new vector 3D. So again, you see this is a type. This is a grasshopper type that we define. We have these grasshopper types. Why? Because on the top of the list here, we have been using, these are the C# ones, and this is the C# for Rhino. This is like Rhino is a library, Rhino.geometry, grasshopper, grasshopper.kernel, grasshopper.kernel.data. This is where we had those like GH underline path or something, grasshopper.kernel.types. These are the types that we use in Grasshopper. So because we imported these, we use this, we can basically play around with vector 3D, point 3D, plane, curve, polyline curve, NURBS curves, whatever. Then we have like here, where were we? Okay, so then defining the start point of the curve on side right and side left, curve list definition, generating initial horizontal lines, the curve lines along the sheet direction. Then again, like defining the cut polygons, main curve bending, and returning values and setting by reference parameters. So it's like these are the by reference parameters and then returning the value. And these are all the side functions that are used there. So you see, this code is actually abstract. It's like, these are just some things which you look like, okay, nice. There is a function called info that does everything for me. Amazing. There is a function called, I don't know, PL length that does something. There is a function which is called parallel finish, which does something. These functions are all declared here. So now we have a polyline curve, means it returns a polyline curve. It is a method that returns a polyline curve, and it's called try from points. So it produces triangle from 3 points immediately for you. Then we have like a list of curves. This returns a list of curves, poly from horizontal lines. So you give some horizontal lines to it, it produces a polyline for you out of those horizontal lines. How? It takes care of everything. So I've been using this several times in the code. Imagine instead of one line of code, I had to copy paste this several times. So if something was not working and if I wanted to change something, I had to change this 10 times. But now I don't have to. You remember I said there is an operator that I will explain later, and it's called ternary. I just show it to you here quickly. There is a way that we can make a very short if situation. Do a search about it later about ternary operators, but it's like we say I equals 0. This is a condition. Then question mark something, column something. It's a very simple thing. It says if this condition comes true, return the first part. If this condition comes false, return the second part. So if I was 0, return 0. If I was not 0, return curve moved on.